Imagine looking out your window and realizing the ground beneath your house is no longer solid. It is slowly turning into liquid. Now imagine this isn't just happening to your home, but to your entire city, your state's highway system, and an 800-mile-long pipeline carrying millions of gallons of crude oil. This isn't a dystopian movie plot. Right now, across the vast expanse of Alaska, the foundation of the state is literally melting. Critical infrastructure, from schools to runways, from suburban homes to the Trans-Alaska Pipeline, was built on the promise of permanently frozen ground. That promise has been broken. We are watching an impending infrastructure catastrophe unfold in real time, and national risk assessments are largely ignoring it. But the bill is coming due. Recent scientific models, utilizing deep learning satellite analysis, have mapped out the devastating scale of this crisis. The estimated repair bill is set to explode past $37 billion by mid-century, and in a worst-case scenario, it could top $51 billion. Stick with me until the very end of this video, because the final, terrifying reality of what happens when the massive Trans-Alaska Pipeline's foundation turns to liquid will completely change how you view the fragility of modern engineering. To understand why a $50 billion collapse is happening, we first have to understand the ground itself. When engineers and settlers moved into Alaska over the last century, they encountered permafrost. By definition, permafrost is ground, soil, rock, sand, and organic material that remains completely frozen at or below 0 degrees Celsius for at least 2 consecutive years. In many parts of Alaska, this ground has been frozen solid since the last ice age, tens of thousands of years ago. When you build a house, a highway, or an airport runway in the lower 48 states, you dig down to stable bedrock or compacted soil, pour a concrete foundation, and build up. But in Alaska, the permafrost was the bedrock. It was as hard as concrete. As long as you didn't accidentally heat the ground underneath your building, the foundation was considered entirely stable. But what happens when the entire atmosphere begins to heat the ground for you? Have you ever left a block of ice in the sun and watched it turn into a puddle? Now imagine that block of ice is holding up a 3-story building. The Arctic is currently warming up to 4 times faster than the rest of the planet. As the ambient temperature rises, the heat penetrates deeper into the soil. The permafrost isn't just pure ice. It is often ice-rich, meaning massive wedges of pure ice are woven through the dirt and gravel. When that ice melts, it doesn't just make the ground wet. The ice physically takes up space. When it turns to water and drains away, it leaves massive subterranean voids. The ground loses its structural integrity and collapses inward, creating a slurry of mud and sinkholes. This process is called Thermokarst subsidence, and we built an entire modern civilization right on top of it. For decades, the true cost of this melting foundation was vastly underestimated. Government risk models often looked at the Arctic through a blurry lens, guessing at the scale of the infrastructure. But recently, scientists deployed advanced deep learning AI to analyze high-resolution satellite imagery across 285 Alaskan communities. What they found triggered absolute panic in civil engineering circles. The AI revealed that the amount of infrastructure sitting in the crosshairs of permafrost thaw was almost double what previous literature had claimed. We are talking about an astounding 53 million square meters of building footprints and over 50,000 kilometers of roads. This isn't just a few cabins in the woods. This is the arterial network of an entire state. As the permafrost thaws, the damage isn't dramatic and instantaneous like an earthquake. It is a slow, agonizing, and incredibly expensive mechanical failure. Think about the roads. Highways built on permafrost are suddenly dropping into massive depressions. The asphalt cracks, buckles, and splits in half as the ground beneath it liquefies. Think about the airports. In remote Alaskan communities, the airstrip is the only lifeline for food and medical supplies. When an airstrip develops sinkholes from thawing permafrost, it becomes too dangerous for cargo planes to land. Think about the homes. Houses are literally tearing themselves apart. As one side of a house sinks into the melting mud and the other stays frozen, the structural framing twists. Windows shatter in their frames. Doors refuse to close. Eventually, the house snaps. The financial toll is staggering. Under a medium emissions climate scenario, the cost to repair and replace this failing infrastructure by mid-century is projected at $37 billion. Under a higher emissions scenario, that number skyrockets to $51 billion. To put that in perspective, the entire annual state budget of Alaska hovers around $10 to $12 billion. The state is facing a repair bill it simply cannot afford, and national U.S. risk assessments historically fail to even account for permafrost hazards. If your house was slowly sinking into the earth, and your insurance company refused to acknowledge that the ground was melting, what would you do? While the $37 billion figure covers paved roads and permanent buildings, there is a hidden crisis that doesn't make the official ledgers. It is the collapse of Alaska's vernacular infrastructure. In rural Alaska, communities rely on ice roads, winter trails, and frozen rivers for up to 6 months of the year. These aren't paved highways, they are transportation networks made entirely of frozen water and compacted snow. They provide at least 4,000 additional miles of temporary roadways that allow heavy fuel barges, construction equipment, and essential supplies to reach isolated villages at a fraction of the cost of flying them in. As the Arctic warms, the season for these ice roads is drastically shrinking. Rivers are freezing later and thawing earlier. The ice is becoming dangerously thin, unable to support the weight of heavy supply trucks. When these natural, frozen highways fail, the cost of living skyrockets, as every gallon of diesel fuel and every pound of flour must be flown in on small aircraft. Maintaining these failing winter trails already costs an estimated $20 million a year, a number that is accelerating rapidly. This is the silent, uncounted tax of the permafrost collapse, a slow strangulation of the state's most vulnerable off-grid communities. I asked you to stick around until the end to understand the ultimate, terrifying reality of this permafrost crisis. It revolves around the single most important piece of infrastructure in the state, the Trans-Alaska Pipeline System. Built between 1975 and 1977 at a staggering cost of $8 billion. This 800-mile steel artery carries millions of gallons of crude oil from the freezing shores of Prudhoe Bay down to the ice-free port of Valdez. It is one of the greatest engineering marvels in human history. But there was a massive problem during its design. The oil flowing through the pipe is hot. Crude oil comes out of the ground warm, and the friction of pumping it keeps it hot. If you bury a massive pipe full of hot oil directly into the permafrost, the pipe will melt the ground around it. It will sink, snap, and cause one of the worst environmental disasters in global history. So, the engineers had to adapt. For roughly 420 miles, more than half the pipeline's length, the pipe is built completely above ground, elevated on massive steel supports called vertical support members. Because 75% of the pipeline's route crosses permafrost, these steel supports had to be driven directly into the frozen earth. But the engineers knew that the steel supports could conduct heat from the sun down into the permafrost. To prevent the supports from melting their own foundations, they invented Thermosyphons. These are sealed tubes filled with anhydrous ammonia. During the winter, the ammonia absorbs heat from the ground, turns into a gas, rises to the top radiator fins, releases the heat into the freezing Arctic air, turns back into a liquid, and flows back down. It is an ingenious, passive refrigeration system designed to keep the ground around the structural supports permanently frozen. Here is the terrifying big fact. The Thermosyphons were designed to operate in the climate of the 1970s. They were built on the assumption that the deep, brutal Alaskan winters would always be cold enough and long enough to extract the heat from the ground and keep the permafrost solid. But the climate has fundamentally changed. The winters are growing shorter, and the ambient air temperatures are rising. The passive refrigeration system is losing its efficiency. The pipeline is currently well into its second lifetime, having outlived its original 30-year design span. If the permafrost melts beyond the capacity of the Thermosyphons to keep it frozen, the massive steel supports holding up an 800-mile pipe full of crude oil will begin to slump. The ground will turn to mud. The pipeline will lose its structural alignment. If the foundation of the Trans-Alaska Pipeline collapses, we are not just looking at a $50 billion repair bill for roads and houses. We are looking at the potential failure of the economic spine of Alaska. a catastrophic disruption of American energy logistics, and an environmental nightmare that the state is entirely unprepared to contain. The ground is melting, the clock is ticking, and we are rapidly running out of ice.